The notes for today are in Quadratic and Rational Functions, Unit 4. So what we're going to do is we are going to start with finding the GCF. And this is a topic that you may have done in the past. And we're just going to kind of recap it. And then we're going to start looking at incorporating variables. So first of all, when you hear GCF, that stands for the greatest common factor. So GCF. And from here on out, we will just abbreviate GCF. So a couple of things, an integer, to find the GCF of an integer, like we're going to do for number 1, where it's just numbers, we're going to find the biggest number that is a factor of all of them. And then for a monomial, like number 2, we're going to take out the number that is a factor of all of them. And then we're going to take out what kind of, what variables they have in common. So first off, I do want to make a note that factor means to break down. So just in case if you forget to factor something, we're going to break it down. So break down. All right. So what we're going to do, before we start, if 2 or more integers or monomials have no common factors, if their GCF is 1, then we call them that they're relatively prime, or we just say prime. So if they have nothing in common, we say the word prime. So let's look at number 1. So we have 18 and 24. So to start, I'm going to make a list of what multiplies, and again, whole numbers only, that multiplies to give us 18. So I have 1 and 18. I have 2 and 9. 3 and 6. 4 doesn't work, and 5 doesn't work. And then that's about it. So now I'm also going to look at my numbers for 24. So I'm going to start with 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 does not work, and then we're back at 6, and that's about it. So I'm just going to make this a little smaller so I can make this one fit. So we're making a list of what multiplies to give us those numbers. So now we want to see of our numbers, what is the biggest one they have in common? So yes, they have a 1 in common, but we want to pick the biggest number they have in common because it's greatest common factor. So they both have, let's see here, a 6. 6 is the highest number that they both share. So the GCF for number 1 is going to be the number 6. So it's what they have in common. All right. So let's take a look at number 2. So now we want to find the GCF of 3x squared and 9x cubed. So we're going to do the same things with our numbers. We're going to look at our 3 and our 9. So 3, the only 2 numbers that multiply to give us 3 are 1 and 3, and that makes that a prime number. For 9, we could do 1 and 9 or 3 and 3. So now we want to look to see what number appears in both, the biggest number, and that's going to be a 3. So the GCF of 3 and 9 is 3, but now we have our variables. So notice that we have an x squared and an x to the 3rd. So if we think about this, x squared means that we have 2 x's. X to the 3rd means that we have 3 x's. Well, they both have 2 x's. So x squared is going to be part of the GCF because both of them, you can take out a 3 and 2 x's. So notice that it's going to be the smallest of the variables with the exponent. The smallest exponent is the one that's going to get pulled out. Let's take a look at number 3. So we have 15, and again, I'm just going to focus on my numbers here, 15 and 21. So 15, I can do 1 and 15, 3 and 5, that's it. 21, I have 1 and 21, 3 and 7. So 3 is going to be part of my GCF. And now I'm looking at my letters. I have an a to the 4th and an a squared. Well, it has to have that in common, and we're going to take out the smallest exponent of that letter, which is a squared, and then that is it. yes, there's a b, but 15a to the fourth has no b. So there is no b in our answer. So for it to be a greatest common factor, it has to be in all parts. Let's take a look at number 4. So we have 6 and 17. So I'm going to factor them out. So 1 and 6, 2 and 3. 17 is just 1 and 17. So they only have the number 1 in common. So now let's look at our letters. So we have a p squared and a p to the 5th. Well, we're going to take out the smallest amount of p's, which is p squared. And now our q's, we have q to the 3rd, and this is like q to the 1st power. So we're going to take out the smallest one, which is just q to the 1st power. So our GCF is 1 p squared q. So taking out the number that they have in common, the highest number they have in common, and then our variables, if they have the same variable, we're going to take out that smallest value, which I know is kind of confusing because you're like, what's the greatest? But you're actually taking out the smallest, but that's only for the exponent. So let's look at number 5. So we're going to take 12, 8, and 24. So for 12, we are going to think about, okay, that's 1 times 12, that's 2 times 6, and that's 3 times 4. Those are our combinations that would work for 12, that multiply to give us 12. 8 is 1 and 8, and 2 and 4, and that's it. 24, we could do 1 and 24, 2 and 12. I think we did 24 before. 3 and 8, and 4 and 6. So we want to find out what is the biggest number that all 3 have in common. So the biggest number that they all have a 4. So we'll have 4. And I do realize that this one has an 8 and this one has an 8, but 12 does not. So that's why 8 does not get pulled out. Now we're looking at our x's. We have x to the 3rd, x to the 7th, and x squared. Well, because they all have an x, we're going to take out the smallest amount. So they all have at least 2 x's. And then for number 6, same thing. We have a 6 and 11. So 6 is 1 times 6, 2 times 3. 11 is prime, so that's 1 and 11. So they have a 1 in common. Now let's look at our letters. They have an a to the 3rd, but that's it. There's no a to the 3rd over here. So we can't take that out. B squared, that's it. Can't take that out because there's no other b squared. Same thing with c squared. So the GCF for this one is 1. And what we say when it is just the number 1 is that it's prime. So they have nothing in common, besides the number 1. So we would say that that is a prime GCF. So at the bottom here, what to look for? So for integers here, you're going to find the GCF of all integers or coefficients. Remember, coefficients, the number that's in front of the letter. And variables, to find the GCF of that, it must be in all terms, and you have to take out the lowest one. So they all have to have that letter, and then you're going to take out the smallest amount. Okay, so there are some for you to try on the next page. So we will recap that when I get back tomorrow. And then we're going to take a look at LCM. So for LCM, what we're going to do is we're going to look at multiples. So first of all, LCM, stands for least common multiple. And a multiple is a number that it's like kind of like a times table. So for example, I know you can't really see it says example there, but for 5, the multiples are 5, 10, 15, 20. So basically you're looking at, okay, what's 5 times 1? What's 5 times 2? What's 5 times 3? What's 5 times 4? So you're listing all of those multiples. So when we go to do the least common multiple, we're going to list out all those numbers. And then we want to look to find out which one's the smallest. So that you really want to have your calculator handy for these problems, because some of them can kind of get a little crazy, especially if you don't know your times tables that well. So let's jump into the first one here. It says multiples of 6. So I'm going to make a list. I have 6. That's 6 times 1. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. I'm going to kind of stop there. Multiples of 10 are 10, 20, 30, 40, and we could keep going. Well, I'm going to stop here because I see a 30 in both of my multiples. So 30 is the smallest multiple of 6 and 10. So let's take a look at number 1. So we have 4 and 5. So I'm going to do 4. I'm going to do 5. So 4, my 4 times tables is 4, 8, 12, 16, 20. And I'm going to stop there because I know 20, that 20 is a multiple of 5. So if I go and do my 5s, I have 5, 10, 15, 20. Well, there is my lowest or my least common multiple. So LCM for 1 is going to be 20. Let's take a look at number 2. We have 8 and we have 12. So 8 times tables is 8, 16, 24. And I'm going to kind of stop there because I know 24 and 12 have a connection. So I'm going to just check my 12s. So 12 times 1 is 12. 12 times 2 is 24. So there's my LCM, 24. All right, 6 and 8. My 6 times tables, 6, 12, 18, 24. Again, I know 24 and 8 are connected. So let's do the 8 times tables. And there's my 24. So we're looking to see what number that they have that's the same. That's the smallest. And then the same thing for 9 and 21. I might start with the 21 first because I'm not really sure. So this is where your calculator comes in handy. So 21 times 1 is 21. 21 times 2 is 42. 21 times 3 is 63. Well, I know 63 and 9, they can be divided by each other. So I'm going to check my 9s. So I have 9, 18, 27, 36, 45, 54, and then there's my 63. So 9 and 21, the LCM is 63. So the very last part of this is now doing with variables. And it's just like what we did up top here, but now we're going to take the highest amount of variables with the exponent. So for example, if we do the LCM of 9 and 15, so 9, I'm going to start with 15 first. So if I do 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45. I know 45 can be divided by 9. So I'm going to do my 9, my 18, my 27, my 36, my 45. So there I have 45. So LCM is going to be 45. And now what we're going to do is we're going to take the highest exponent of every variable. So there's an x and there's an x squared. So we're going to take the biggest, which is x squared. Looking at our y's, we have a y to the third and a single y. So that's going to be y to the third. And then our z, we don't even have a z in this guy over here, but we have a z squared. So that also is going to be part of your answer. So even though it says least common multiple, you are taking for the variables the highest exponent of anything that you have, where GCF was the smallest number. So we're going to jump down to problem 3. And we want to find the LCM. So we have a 5 and we have 16. So what I'm going to start with first is 16, because I'm not really sure about the times tables. So 16 times 2 is 32. 16 times 3 is 48. Times 4 is 64. And then we hit 80. And I know 80 and 5 can be divided. So if I go 5, 10, 15, 20, I'm going to end up hitting 80. So I know 80 is going to be my number for my LCM. Now for my letters, I have an a to the third and an a to the fifth. Well, I'm going to pick the highest amount, which is a to the fifth. And then that b is by itself. That's going to come along with our answer. So you're taking the highest amount of what you have. Let's take a look at number 4. So we're going to do 21 and 9. And I'm going to start with the 21 first. So again, using my calculator, I know 1 and 21 is 21. 21 times 2 is 42. 21 times 3 is 63. I know 63 and 9 can be divided. So if I go through my 9s, I got 9, 18, 27, 36, 45, 54, 63. So 63 is my LCM. And then I have a W and a W squared. Well, we're taking the highest amount, which is W squared. Okay, so we're going to jump down to, let's take a look at number 7. So we have 3 terms this time, 8, 2, and 12. So we're going to look at all of their times tables. And I'm going to start with the 12 first, just because that is the largest. And I know 24, 8 can be divided by 24, and so can 2. So I'm going to stop there. You know, if you wanted to, you could work out all your numbers, but 24 is going to be there, 8, 16, 24. So they all have a 24 as a multiple. Now, looking at our letters, we have an a to the third, an a squared, and an a squared. Well, a to the third is the biggest, so that's going to be the LCM. Now looking at our b's, we have a squared, a single b, and a b to the fifth. So we're going to take the biggest one, which is b to the fifth. So we will work on more of this tomorrow, but just to kind of give you a preview. So just to kind of go back up top here, GCF, you are writing down what multiplies to get you that number and seeing what is the biggest number that they have in common. If you have a letter, you take the smallest exponent if they all have that in common. LCM, on the other hand, you are taking basically the times tables, figuring out, okay, 4 times what? 4 times 2, 4 times 3, seeing what number they have in common. If there's a variable, you take the biggest amount that they have. Again, this is just to kind of give you a preview. We will definitely work more on this tomorrow.